Hi, it's great pleasure to go over machine learning. Machine learning is popular in many applications. For example, finance, medicine, biology, physics, and data science. Let's take a look at the motivation of machine learning. Suppose that you have a check written by someone else and are depositing it at an ATM. The most important information on the check is the amount. You must have experienced that the ATM failed in recognizing the digits when those digits were written by hands, so you had to provide the machine with the amount by pressing keys. This slide shows digits from 0 through 9, and they were written by different people. Different people write the same digits differently because their handwriting styles are quite different. Can you tell what makes each digit? If you make a program that recognizes handwritten digits, it will be very complicated. To solve complex problems, we need machine learning. Machine learning models learn underlying patterns of the training data. Those trained models answer queries that are unseen data. Unseen data are data sets that were not included in the training data. Predictive modeling is one of the examples of machine learning. Once those predictive models are trained from the training data, they return the prediction of the unseen data. These digits can be used as a training set. Once a machine learning model is trained using this data, it can recognize handwritten digits that are not included in this training set. There are numerous applications of machine learning: spam filtering, credit card fraud detection, digit recognition on checks, detecting faces and images, MRI image analysis, recommendation system, handwriting recognition, send classification, and etc. There are different types of learning. In supervised learning, training datasets have known class labels or dependent variable. The learning models are trained by using labeled data or data with response variable. Classification is a supervised learning. Learning models are trained by the labeled data, then classify unlabeled data. Regression models are trained by data with known response values, then predict the response values of unseen data. Deep learning models are trained using training data with known classes, then predict the classes of unseen data. Clustering is unsupervised learning. Clustering methods discover clusters of data points from data with unknown classes. In classification, classifiers are trained by training data with known classes, then the classifiers categorize unseen data into a distinct number of classes. A customer walks in a computer store. The store assistant's interest would be whether the customer buy a computer. The table shows the training data with known classes. The training data consists of 4 attributes: age, income, student, credit rating, and one class variable: buys computer. The training data is used to train a classifier. Once the classifier is trained, it can answer the question: when age is youth, income is medium, the customer is a student, and the credit rating is fair, will the customer buy a computer? The decision tree induction is a classification method. Decision trees are constructed from the training data by the decision tree learning algorithm. There are 4 variables in the training data, but the decision tree learning algorithm excluded the income variable. Given a decision tree, we ask the decision tree the question: when the customer profile is as follows: age is youth, income is medium, student is yes, and credit rating is fair, will this customer buy a computer? By this decision tree, the answer is yes. Regression is supervised learning. Regression finds a linear or nonlinear function that predicts the outcome given the independent variables. Independent variables are called predictors, and outcome is called a dependent variable. Suppose that the function you derive from the training data is a linear function of the 3 predictors. The function returns the predicted house unit price given in a query. If house age is 20, the distance to the nearest mart is 20.6, and the number of convenience store near the house is 7, what is the house unit price? Deep learning is a type of supervised learning. Deep learning models are based on the artificial neural network. There are no magic numbers of hidden layers and hidden nodes in constructing artificial neural networks because they are highly dependent on the data. Given data, Machine learning people find the best number of hidden layers and hidden nodes empirically. Typically, 1 to 3 hidden layers are used. The deep neural networks consist of a large number of hidden layers and hidden nodes. Clustering is unsupervised learning. Given a data set, clustering methods discover a set of clusters. The classes of data points in the data are unknown. Classification methods learn the decision boundaries from the training data because the training data has known classes. Then, the methods predict the classes of data points in unseen data. On contrast, clustering methods discover clusters of the data to estimate the true classes of the data points. After discovering clusters, the methods estimate the true classes of unseen data. Suppose that a botanist is given a set of flowers. The flowers look similar. However, they don't different. The botanist's task is to find the classes of those flowers. To find the clusters, he measured petal and sepal. Petals are leaves that surround the reproductive parts of flowers. Sepals are the parts that protect the flower and bud. The training data has the sepal lengths, sepal widths, petal lengths, and petal widths of 150 flowers. K-means clustering algorithm is a clustering algorithm. K is an estimated number of clusters. In the first iteration, it starts with 3 initial cluster centers, calculates the distances from the 3 cluster centers and all of the data points, assigns each data point to one of the 3 clusters based on the shorted distance between the data point and cluster centers, then updates the cluster centers. In this example, the distances between the 3 cluster centers and data points are calculated by using Euclidean distance. The updated cluster centers are the averages of the data points in each of the cluster. In the second iteration, all of the steps performed in the first iteration are performed. In other words, the algorithm calculates the distances between the updated cluster centers and all of the data points, assigns each data point to one of the 3 clusters based on the shorted distance between the data point and cluster centers, then updates the cluster centers. Before proceeding with the next iteration, the algorithm checks the stopping criteria to see if more iteration is needed. Examples of the criteria are whether there is any change in the cluster membership or any change in the cluster centers. The data analyst decides which criteria to use. Infinite iteration is prevented by using the stopping criteria. After the botanist discovers the 3 clusters of the flowers, he names the 3 cluster of those flowers. Suppose that the 3 cluster names are Sets, Versicolor, and Virginica. The attributes of the unseen data point are sepal length is 5.6, sepal width is 2.8, petal length is 4.9, and petal width is 2.0. What is the class of this iris flower? All your program needs to do is to calculate the distances between the data point and the 3 cluster center using the Euclidean distance, then identify the cluster whose distance with the data point is the shortest. You might have a question. How does the data scientist estimate the optimal K, which is the estimation of the true number of clusters? The general method is to use the cluster validity index. The cluster validity index estimates the number of clusters that minimizes within cluster distance and maximizes between cluster distance. Each of the cluster validity index provides a mathematical equation that calculates a single real number. The number is the measure of the cluster quality. You need to pick one cluster validity index method, implement it, set the K from 2 to maximum number of clusters in your code, calculates the cluster validity index value with each of K, then identify the best K based on the measure. If you have difficulties with estimating the maximum K, you can use another clustering method. It is agglomerative hierarchical clustering. Agglomerative hierarchical clustering algorithm let users determine the clusters using a visualization method which is called dendrogram. This slide shows an example of the dendrogram. The dendrogram visually shows which data points are in the same cluster and give users the control to that cutoff point. If the user cuts the linkage at this cutoff value, 2 clusters are discovered. If the user cuts the linkage at this cutoff value, two clusters and one singleton are discovered. This agglomerative hierarchical clustering is popular in analyzing biological data. This slide shows various data distributions and various clustering algorithms. Each row represents different distributions of data, and each column represents different clustering algorithms. When the data is linearly separable, it's easier to discover true clusters than non-linearly separable data. Given data, it's totally up to the data scientist to choose which clustering algorithm to use. These datasets are two-dimensional data. If the dimensionality of the data is higher than 3, it's hard to visualize the data. Therefore, it's important to choose the right clustering algorithm and the cluster validity method for the data. Each of the machine learning models will be reviewed in more detail in upcoming videos.